Hello everyone, welcome back to Pepcoding. So the question which we will discuss today is called abbreviation 1, but this time we are doing it using bits. You have done this question previously when we were discussing about recursion. Okay, so I'll give you a gist of the question first and then we will discuss how we are going to do this question using bits. Okay, so basically what you had to do was that you were given a string. For example, in this case it is pep. Okay, now what you have to do is you have to print all of its abbreviations. And abbreviations in what manner? See, the string is of the length 3, so here we will have 8 abbreviations. So from 0 to 7 I will write over here. Okay, this becomes 0 0 0, this is 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. Okay, so we have to work with this. Now see, when we are working with bits, this is always the 0th position, this is the first position and this is the second position. Over here, this is the 0th position, this is the first position and this is the second position. So remember that. What you have to do is you have to print the abbreviations. So what will be the abbreviations? This will become, whenever you have 0, you will print the corresponding character, and if you have 1, you will stop that character from being printed. So what will be the output? This will be PEP, this is going to be PE1, this is going to be P1P, this is going to be P2, this is going to be 1EP, this is going to be 1E1, this will be 2P and this will be 3. Okay, so this is what you have to print. Now let us discuss how we are going to do this with the help of bits. Okay, so I'll write this again, all of it. Let's say we have PEP. So we can write 8 abbreviations for it. Why 8? 2 to the power 3. Okay, the length of the string is 3, so we can have 8 abbreviations. So 4, 5, 6 and 7. This will become 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. So this is what we have to work with. Now see, as I discussed, this is the 0th bit, this is the first bit and this is the second bit. Over here, this will be the 0th bit, this will be the first bit and this will be the second bit. We will start from the 0th bit of the string. So we have to start by comparing with this bit only. Okay, so what we are going to do? See, over here we have 0. So it is corresponding to P. P will come as it is. I'll write the output over here. Okay, so this is going to be output. So 0 is corresponding to P and it is 0. So P will come as it is. Similarly, this is corresponding to E. Here we have 0 corresponding to P. Then 0 is corresponding to P, 0 is corresponding to E. But now in place of this P we have 1. So what will happen? This one will not let me print P. Okay, we will keep a variable count. Alright, every time we come across 1, we will increase the count by 1, otherwise we will let it be 0. So over here I have count 0. Now this position is giving me 1, so it will not let me print P. So I'll increase count by 1. Then I'll come over here. The string is now done traversing. So we will print this count and then make it 0 again. Okay. So now over here in the next place, over here count is 0. Okay. Then for this position, for the second abbreviation, that is 0th first and second abbreviation, over here we have 0. Now here we have 1, so it will not let me print E. So count will increase by 1. Okay. Now I move to the next position, I come across 0. So when I come across 0, I will check if the count is greater than 1. If the count is greater than 0, then I will first print count. Then I will print the character corresponding to this 0. And then I will make count back to 0. I'll repeat this part. Over here we had 0, 1, 0. So I said that count is 0 in the starting, right? Here we had 0, so P will come as it is. Now we have 1. So 1 will not allow me to print E. So count will be increased and it will become 1. Okay. Then I move to the next position. I come across 0 and it is corresponding to P. But every time we'll first check whether count is greater than 0 or not. In this case, yes, count is greater than 0. So over here we will first print the count, then print this character, then make the count 0 again. Okay. Similarly, moving to the next one, here count is 0. Okay. This was 0, so P will come as it is. Then this is 1. It will not let me print P. It will not let me print E. So count will be increased. Then I come to 1 again. It will not let me print P. So count will be increased again. Then I go to the next place. The string is complete. So we will simply print the count and make this count 0 again. Okay. Then to the next abbreviation, we have count to be equal to 0. Here we have 1. So it will not let me print P. I will make this 1. I'll come to the next position. I found 0. So first I will check. Since the count is greater than 0, so first print count, then print your character, then make the count 0 again, and then move to the next position. Now here I have 0 again, so this will become 180. Okay. For the next position we have count 0. I got 1. It will not let me print P, so it will become 1. I move to the next position. I found 0. So what will I do? Count is greater than 1. Print count. Print your character. Make count back to 0. Go to the next position. Okay. Again count is 0 now. Then over here I have 1. It will not let me print P. Count becomes 1. Go to the next position. There is nothing. The string is over. Print the count and make the count 0 again. Okay. Next place we have count as 0. So this is 1. Will not let me print P. Count becomes 1. Next position we have 1. It will not let me print E. It will become 2. Next position I have 0. Okay. So first thing I will do, I will check count is greater than 0. So I will print the count, then I will print the character, then count will become 0. Final one, I have count as 0. Okay, so over here I have 1. It will not let me print P. I will make the count 1. Next position, I will check it is 1. It will not let me print E. So I will make the count 2. Then I come to the next position. Again I found 1. It will not let me print P, so count will become 3. I'll go to the next position. The string is over, so I will simply print the count. Okay, and then count will become 0. Then after that, I have nothing to print, right? Because I only could move for 8 iterations or 8 abbreviations. So these will be my output. Now let's try to do this using code as well, and I'll keep on explaining simultaneously what we are doing and why we are doing it. Okay, so now we'll do this using code also. Alright. So see, the first thing which we need to do is we need to find out or figure out the number of abbreviations. So we discussed that the number of abbreviations which we need is 2 raised to power 3. Why? Because the string PEP was of the length 3. So basically we need 2 raised to power length of the string, right? And how do we find out 2 raised to power anything? Using bit manipulation. We do left shift of 1. So if I do left shift of 1 by 3, I will get 1,000,000. Originally 1 is something like this. So if I do left shift of 1 by 3, I will have, right? And this will be 8. So I needed 8 abbreviations only. So what are we going to do? That over here we will have for int I equals 0, I is less than 1, left shift str.length and I plus plus. Okay. After that, I need to move in my string. The thing was that if PEP was like this and the abbreviation or the binary representation which I was working on was this, so this has 0, 1 and 2, whereas over here we have 0, 1 and 2. But we need to work for the string, right? We need to work for the string, so we will start from the 0th position of the string only. So over here I'll have for in j is equal to 0, j is less than string dot length and j plus plus. Okay, and the bit with which we are working in our binary representation is the MSB, right? We are starting from the most significant bit, most extreme bit. So over here that can be represented as str dot length minus 1 minus j, right? And we need our character with which we are working. So str dot char at j. Okay, so this is what we'll get. Now we need to figure out whether at any position we have 0 or 1. That means we have to figure out whether it is on or off. So how did we find that? If 1 and or if I and 1 left shift B comes out to be 0 is equal to 0, then in that case it is on, otherwise it is off, right? So if the bit was 0, then also we had two conditions, that either our count can be 0 or count can be 1. Count can be 0, else count will be 1 or greater than 1 maybe. So over here I need to initialize count as 0. Okay, also I need to put all the characters from the string in a string builder. So I'll create a string builder over here. String builder sp is equal to new string builder. Okay, so if count was 0, I need to directly append it to my string builder. I'll simply print it, right? Otherwise, if count was greater than 0, then first we needed to append the count, then we appended the character, over here it will be append, and finally we will append the, finally we will make the count as 0. Okay, otherwise if we had 1 at any bit was equal to 1, then in that case we simply increase the count. Also, after we exited the string, like when we were done traversing the string for that particular abbreviation, we had a condition where count was greater than 0 even after completely traversing the string, right? So in that case, we will append count to the string, right? And after that, we will print the string. System.out.println SB, right? So now let us try to run this program. Okay, there are errors. It is expecting a bracket. Okay, right, over here we've missed the bracket. So now let's try to run this. Okay, it is saying this is an illegal start of expression. So let us figure out what is wrong with this. Okay. Thing is, I have added a bracket over here, right? We needed to add the bracket here only. Now let's try to run this. And there is no suitable method found for append. Okay. Have I not? I have created the string builder. Okay. Okay, so see, over here we needed ch. Now it is correct. Okay, now we'll submit this. And we have that pass the test cases. So we discussed about abbreviation and we discussed this using bit manipulation instead of recursion this time. So I hope you were able to understand the video and what we did to solve this problem. So thank you for watching the video. We will see each other the next time. Till then, please like, share and subscribe to the channel. Thank you.